So welcome back to the channel. Today I would like to explain this CRUD Lambda, which is supposed to support CRUD operations, so create, read, update, delete on a DynamoDB database. So we are going for a monolithic Lambda approach. This is a sort of an anti-pattern. First of all, what is a monolithic Lambda? Instead of one Lambda per each entity, you have one Lambda to rule them all, so to speak. You look at the path and you look at the method. If this method is like this, and if this path is like this, then do this thing. If this path is like that, then do the other thing, right? This is a monolithic Lambda. So, because sometimes you want speed of development, right? That's argument number one. Number two, I wanted to be able to easily add new entities to this Lambda. Like, if I have these routes, I have quests, achievements, and characters. What if in the future, I want to add a new entity, like I want to be able to create NPCs, and to have all these verbs available, and I just don't want to create a new Lambda, and it's just cumbersome. Because what if I want to change the implementation for all of these? What if I want to change the database? I'm gonna have to change multiple Lambdas almost on the fly. As usual, the code is in the description box below. Check it out. It's less infrastructure to create and monitor. If you want to have a really quick prototype, and you need less time to get it done, I think it's a good thing. At some point in the future, we want to stop using DynamoDB for whatever reason. We want to switch to RDS. So it's much easier to refactor one single Lambda than 10. And then since everything is generic, I will show exactly how easy it is to just change the implementation, like not have DynamoDB, but some other repository. Let's see how this Lambda is structured. As I said, full code is in the description box below. So check it out. We have this backend folder. We have a folder called Lambda functions. Okay, so let's go into the code right now, because I think it's quite exciting. I would like to show how I made it almost fully generic. When you create, obviously, a Lambda project, you get two folders per Lambda. You get source and test. First of all, how does a Lambda start? We have a function. We pass in an environment variable for the table name, and the entry point is called function handler. I needed it to do different things based on the request path and based on the method. So how do we achieve that? So first of all, let's see what happens here. So if the request path wanted achievements, then what I'm doing is I'm initializing a domain service, which is domain service is what I mean by I did not want to copy paste a service to create an achievement service, then a quest service and whatnot. So I just said, okay, it's a domain service of type T, where T is the model, right? And model can be, if we go into models, achievement inherits from model, achievement inherits from DynamoDB model, which inherits from model, right? So at the end of the day, all models, achievement character, they belong to model, right? And why is there this type DynamoDB model? Well, because unlike an actual model of type T, which a model can have an ID, but a model cannot have a partition key. Partition key is something specific to DynamoDB. So that's why I'm creating a class called DynamoDB model of T, inherits from model T, which is an abstract class that implements the necessary things. Like, for example, when you create a model, you always initialize it to its ID to some new GUID. And you have these methods from JSON and, perhaps I should rename this to JSON. But all models should be able to be serialized and deserialized back. This class implements partition key and sort key. So sort key is going to be a property specific to DynamoDB model, right? That's why it does not belong here in the model. And then if I want to just simply swap to a different implementation, when I'm initializing my service, I can say RDS repository. As long as I create a new repository which inherits from this interface, a repository of T, I can just swap with another repository, another database implementation. It's that easy. And it limits the T to only be DynamoDB models, because this is a DynamoDB repository. Obviously, it's going to always need DynamoDB models, which have the characteristic. Why is this necessary? Because they have the characteristic that they all need a partition key and sort key, and I want to always initialize the DynamoDB models sort key with the type of t.name. What this gives you is, for example, if the DynamoDB model is called achievement, this will give you the string achievement. And the beautiful part of this is if I want to just create a new entity, like let's say I create NPCs. Then I say if request starts with achiever NPCs, repository of type NPC, and what this does, when you go to, let's go a bit into this implementation. How does DynamoDB know what entity to give you? What happens is that DynamoDB v2 have different models, right? And this is called the object. What I'm using here with these, what you see here, context query async, context load async, belong to the object persistence model. But it also has other models. But the easiest to work with is object persistence model. What's cool about this model, what I really enjoy, is that if you go to models, all you need to do to support this model, in the repository, you just need to say, load me a type T. All I need to say on the class achievement in order to make it loadable by DynamoDB, I need to add this attribute, DynamoDB table with this name. You just use generics and it just works. What the domain service does is it implements them in a generic way. So like you can create an object and it's of type T. You don't say here, create, but initially I had like this. I had create achievement service, and then create achievement, delete achievement. Well, I had a lot of copy paste in these methods, but that was awful. So I just made it generic. And now in order for this to be an actual service, it just implements create, delete, get single. The handlings are of course accounting for the fact that there is no specific type in this class domain service. And definitely this is most probably an anti-pattern. This might be overkill, but I think it pays off to be able to add more entities later on almost on the fly. And let me know if you have any comments. Please subscribe. For the next episode, I think I will go into AppSync and GraphQL because we want to add to this application some real-time functionality, like it should, the achievements should listen to quests and they should react automatically. So yeah, I think it's gonna be a really cool series. So yeah, stay tuned and have a nice day and or night, wherever you are. And yeah, cheers, bye.